As mentioned in our last video, there are going to be two different approaches to the chain rule. One of them is referred to as the inside-out approach to the chain rule. Now, this is going to be specifically for one case, and that one case being that we are dealing with the composition of exactly two functions. Anytime you have a composition of more than two functions, we're going to go with the outside-in approach. So the technique that we'll be using here is to identify the so-called inside function and perform a substitution on it. Now, usually what we do is refer to that inside function as simply being the function u. Then we're going to take some derivatives. Specifically, we are going to be taking the derivative of y with respect to u and the derivative of u with respect to x, at which point we are going to multiply them and substitute back. So again, the full version of that version of the chain rule is that dy over dx is equal to dy over du times du over dx. So allow me to demonstrate this with a couple of examples. Something mentioned in the previous video would be f of x is equal to x squared plus 1 raised to the 117th power. Little bit excessive, but when I made the problem, I was, well, excited about math. So, first thing we do is identify the inside function and allow that to be our u variable. So the inside function in this case would be the thing inside the parentheses, that's x squared plus 1. At this point, we now have what is going to be referred to as f of u, and this will be u raised to the 117th power. The idea is, once we've made this substitution, we're going to differentiate this with respect to u, and differentiate this with respect to x, and then multiply the two together. So f prime of x is going to be equal to the derivative with respect to u of f of u, that's just using Leibniz notation instead of our Newton notation, then we'll be multiplying by du over dx. So u to the 117th power will be 117 times u raised to the 116th power. And then the derivative of u with respect to x will be times 2x. At this point, we are going to simplify as much as possible. And the simplification is going to be 2 times 117 is 234. We'll still have an x. And we'll still have a u raised to the 116th power. The difference is we now need to substitute back and plug in what u is equal to so that our final answer is in terms of only one variable, that one variable being x. So again, this is really only useful if you have a composition of exactly two functions. Let's try another. Let's do y is equal to, let's do the sine squared of x. Now, to interpret the sine squared of x, this is in notation only that we call it the sine squared. What we're really doing is squaring the sine of x. Now, in that notation, it makes it a little bit more obvious what our inside function is. We're going to let u be equal to the sine of x. Then we would have that y is equal to u squared. So once again, the idea is we're going to be differentiating this function with respect to u and differentiating this function with respect to x and multiplying the two together. So dy over dx is going to be equal to du over dx, and then we'll multiply that, might as well color coordinate here, by, oh no, these colors are backwards. Let's try that again. Dy over du times, now we're color coordinating. Never count on a single guy to color coordinate. So dy over du, that'll be the derivative of this function with respect to u, so that'll be 2u, times the derivative of u with respect to x. That'll be a cosine of x. Then once we substitute back and get everything in terms of one single variable, that'll be 2 times the sine of x times the cosine of x. And that would be our final answer. Now I wanted to do a comparable problem where we're simply reversing a couple of things. So for this one, I'd like to do y is equal to the sine of x squared. So same functions being composed as the last one, we're just doing it in the opposite order, where the inside function is now going to be x squared. So we'll say let u be equal to x squared. That way our new function will be y is equal to the sine of u. So once again, the idea is we're going to differentiate this function with respect to u and this function with respect to x, and we'll see what we get. And my pen's gone forever now. This is going well. So, given that the color coordination is completely out the window now, with the blue pen being gone forever, we'll just go ahead and switch to black, the most dominant color. So, that'll be dy over du, that's the derivative of sine of u with respect to u, multiplied by the derivative of u with respect to x. So, sine of u will be cosine of u. We're going to multiply that by this derivative here, that'll be 2x. Reordering this ever so slightly, that'll be 2x times the cosine of, and instead of calling it u, we'll go ahead and substitute back and call it 2x times the cosine of x squared. I think that's enough chaos for one video, so we'll call it right there.